Morning of Roses everyone, my name is Angeline Pasay from Base 81A. So now I am creating a class called Animal. A class is like a blueprint for creating objects. Inside this class and I am going to define behaviors that all animals will have. Public this keyboard makes the code that follows it accessible from outside the class. Anything under public can be used by other parts of the program. I am defining a function called eat. The void means it doesn't return anything. This function will describe what happens when an animal eats. This line makes the program print this animal can eat to the screen. I am creating a new class called Rabbit that is based on the animal class. The public animal means rabbit inherits the behavior of the animal class, so it can do things like eat, but it can also have its own special abilities like jumping. Again, you're saying that everything under public is accessible from outside the class. I am defining a function called jump. This describes the behavior of the rabbit when it jumps. This line prints this animal can jump to the console. I will create the main function, which is where the program starts executing. Every program must have a main function. I am creating an object called object of the rabbit class. Now, object can use all the behaviors of the rabbit class, including things it inherited from the animal class. I am calling the eat function on the object. Since rabbit is a type of animal, object can use the eat function that was defined in animal class. Now I am calling the jump function on object. This tells the program to print that the rabbit can jump. So now we're going to define what is encapsulation. Encapsulation is an object-oriented programming principle where the internal state of an object is hidden from the outside world. It restricts direct access to some of an object components and only allows manipulation through defined methods. This ensures better control, security, and data integrity. In this code, I define a person class with private data members, age, and name. This ensures that the internal state of a person object is protected from direct access by outside code. This method takes two parameters, age and name, and assigns them to the private data members, age and name. It's a setter function that initializes the object states. This function outputs the name and age of the person to the console. It helps in showing the object states. I create an object info of type person. I call person info to set the age and name of info. Then I call display info to print out the details of the person. In this code, I demonstrate polymorphism using a base class shape and two derived classes circle and square. It has a draw method that is declared as virtual. This allows derived classes to override this method, enabling dynamic polymorphism. The method in shape provides a default implementation for drawing a generic shape. Both classes override the draw method to provide their specific implementations for drawing a circle and a square, respectively. A shape pointer is used to demonstrate polymorphism. The pointer first points to a circle object, and when draw to call the circle version of draw is executed, then the pointer points to a square object and the square version of draw is called. In this code, I demonstrate abstraction. It is an abstract class because it contains a pure virtual function draw. This makes shapes incomplete and it cannot be instantiated directly. It serves as a blueprint for derived classes. Both classes inherit from shape and implement the draw method, which is required due to the pure virtual function in shape. Each class provides its own specific implementation of draw, defining how the shape should be drawn. I create objects of circle and square. Each object calls its respective draw method. The draw method of circle prints drawing a circle, and draw of square prints drawing a square.